I am Ranganathan Parthasarathi, Assistant Professor of Structural Engineering in Tennessee State University. I am going to introduce the Structural Testing Lab, and this is for the course CVEN 3400 Structural Testing. And this course is for the senior students to understand and gain experience in concrete compression, mixed design of concrete, curing and testing, preparation of reinforced concrete beam, and mechanical testing, as well as use of finite element simulation for these members. Now I will show you the first experiment. So, because of space requirements, some of the equipments are in the room 105. So the first experiment the students do is the compression test on concrete. The students are trained to operate the Gilson, a concrete compression tester, which is used for this experiment. It can go up to 10,000 psi. It has been calibrated up to 10,000 psi, and the students learn how to operate the load cell and adjust the loading rate so that it is within the requirements as prescribed by ASTM C39 for this test. Uh, the safety jacket is used for the cylinder so that so as to prevent any debris from flying out. In the beginning, the students measure the dimensions of the cylinder and the mass, uh, and after that the cylinder is placed into the compression tester, and the students come in groups of 2 to 3 to take measurements, but a continuous video recording of the measurements is also taken. In addition to the load measurements from the load cell, the students also set up a dial gauge inside the equipment to measure the deformation. So both of these measurements are collected parallelly, and the students will process the data in a spreadsheet to obtain the stress strain curve of concrete and to obtain the fundamental property, which is Fc prime. Then, after the test is over, the students take the jacketed sample out and examine the failure surface. They examine the failure surface of the concrete to see the type of failure surface and compare it to the types which are prescribed, which are shown in the ASTM C39 manual. For this experiment, the properties that the students measure are concrete, the elastic modulus of concrete, the Fc prime, that is the compression strength, as well as the strain at which the peak load is reached. And they compare this to the values that they obtain, the values that they use in the lecture class on reinforced concrete design. Then the second experiment is modulus of rupture of plain cement concrete. This is done using the Statek-Baldwin universal tester, which has 3-point bending. So for this experiment, the students first learn how to operate the universal tester, how to set up the 3-point bending clamps, how to place the plain cement concrete beam for 3-point bending, how to apply the load using the coarse adjustment and finer adjustment on the instrument, how to control the loading rate using the adjustment, and they also use the dial gauge to measure the deformation of the beam at the center of the span. In this experiment, the students measure the modulus, elastic modulus, as well as the modulus of rupture. And in both the first and second experiment, the students also compare the elastic modulus they got with the prediction given in the ACI 318 code for normal weight concrete. So then for both experiment 1 and experiment 2, the students perform finite element simulation using Abacus, for which we have 20 student licenses. And for the simulation of concrete compression test, the students primarily try to observe what is the effect of friction between the surface of the cylinder and the loading plate and how it affects the failure pattern observed. And for the modulus of rupture, we are using 6-inch by 6-inch beam with a 12-inch span. So therefore, there is a considerable deep beam effect. The students also try to simulate this and observe the arch of compression while doing the simulation. So they are able to get a deeper insight into into interpreting the results of the experiment. While the Wilson tester is used to test 4-inch by 8-inch cylinders, we also have the Varlin concrete cylinder compression tester, which is used for the 6 by 12-inch cylinders. And this instrument is capable of going up to 300,000 pounds. The third experiment is mixed design, which is done in room 107. We have two concrete mixers, one larger one of 3.5 cubic feet and also a smaller one. The students they mix the concrete using these mixers for the third experiment, which is mixed design. First, the students use ACI 611 recommendations to come up with the mixed design calculations and proportion the amount of cement, fine aggregate, coarse aggregate, and water for the concrete. And all the weights are taken using the balance. So, especially for this lab, the students take maximum precautions for COVID by wearing protective equipment, and also the doors are kept open to ensure the air circulation. The students are trained on aspects of mixed design, for example, how to get the aggregates, coarse aggregates first to saturated surface dry condition, and other such finer points which will make a big difference in the mixed design. They are also trained how to operate the mixer, and several students together operate the mixer, and they also adjust the mixing angle as well as the rotation. Following this, the mixing of the concrete is done outside, and once the concrete has been mixed satisfactorily, the equipment for slump test, the cone used for the slump test, is carried outside. It is from Gilson company. The students perform slump test on the prepared concrete mix to ensure that it matches their assumptions in the mix design calculation. And if the slump is satisfactory, then the concrete is poured into the 4x8 plastic molds and placed into the curing chamber, which has temperature and humidity control. Then, after 28 days, the students will again perform a compression test to test the compressive strength of this concrete. Then in the fourth experiment, the students, if the fourth experiment is preparation of reinforced concrete beam, and in this experiment the students do it in 3 stages: hand calculation, experiment and simulation. For the hand calculation, the students do it according to the ACI 318 recommendation to predict the the nominal moment capacity of the beam, and usually for this they design 3-inch by 3-inch beam with a 12-inch span, and the smaller size is because of the limitations in the uh, uh, in the in the testing equipment, and also in the formwork available, but we are in future they may go for larger sizes. So after the mixed design, the concrete is poured into wooden molds, and we are in place of the standard rebars. Since the standard rebars are a bit too large for the scale at which we are testing, we are using tie rods in place. The students use tie rods both for longitudinal reinforcement as well as the shear stirrups, and uh, they also calculate, while doing the calculation, they also calculate the nominal capacity in shear. So then the reinforced concrete beam is left to cure in the molds, and after 28 days the students come back to test this. Meanwhile, they also do a simulation of the reinforced concrete beam using special damage plasticity material model for concrete and elastic perfectly plastic model for the steel. And in this way, the students are able to understand all the aspects of design, the how, what is the basis for hand calculation, what are the complexities involved in actually casting the beam, and what are the insights to be gained by simulation. So in this process, we are following a lot of safety procedures. All the students are whoever is setting up the rebar cage needs to wear work gloves, safety glasses, and we are also limiting the number of students who will work on this at a time. So in this lab, about a group of 3 will be working on the reinforcement cage. Then another 2 groups will be working on the concrete mix design, and another small group will be working on creating the cutting and designing, laying out the formwork. So this lab can hold about 16 students at a time, and for each experiment the students are divided in groups of 2 to 3, and since the number of observations are many, each group of students takes part of the observations needed, and finally the data is put together. But we also have video recording of the entire experiment, so that all the observations can be revisited if necessary. The students also get training on how to use the simulation software, what is the concept behind the finite element analysis, how to apply boundary conditions, how to use material models, and how to construct the virtual geometry using CAD tools. So in this lab, further we are following we have safety equipment such as the students easily accessible first aid kit, and also the sanitary equipment needed for COVID. Since in this lab, especially during the mixing and curing of concrete, there is a possibility of closer contact. The students are required to wear protective equipment, and they are always divided into small batches working on particular part of the experiment. Uh, so that is what I want to say about this lab. Thank you.